Hi folks, we're going to take a look at a first example of solving a system of linear equations algebraically. Okay, this can also be seen as finding the point of intersection between these two lines, since both of these equations geometrically represent a line. Okay, so let's see how we can go about doing this. So one thing that often is useful is to place the equations one on top of the other. Okay, and often you'll see me label them. Okay, with a particular number. So this is equation 1, this is equation 2, just to help my solution be a little more organized. Okay, so step number 1 is to isolate one of the 4 variables. Okay, now the one to choose is usually the one that seems easier, and here there's definitely one variable that's very easy to isolate, and that's the x from equation 2, because there's no coefficient in front. So you want to look for variables that either have a coefficient of 1 or even a coefficient of -1 is also nice and easy. So in this case here, I'm going to start with that. So I'm working with equation 2, okay, and I'm going to isolate the x. And that's nice and easy because I just have to bring the -6x to the other side. So that's going to be positive, sorry, the -6y to the other side. So that's going to be positive 6y and then plus 30, since the 30 is already positive on that side. Okay, so step 2 is to now do the substitution. So I'm now going to work with equation 1, okay, and wherever I see an x, I'm going to replace that by 6y plus 30, because that's what x is equal to. And since we're looking for the x value, which is the same in each equation, we can assume that this x has to be the same as that x. Okay, so from equation 1, 3 times here, wherever I see an x, I can now replace that by 6y plus 30, okay, plus 11y equals 3. And now what we have is we have one equation with one unknown, which I can solve. Okay, so now I use my usual tricks for solving this equation. First thing is to simplify both sides, so I'm going to distribute the 3. So here I have 18y plus 3 times 30 is 90, plus 11y is equal to 3. Okay, keep the y's to one side, bring the other numbers to the other side. So 11 plus 18 is 29y, and here 3, and I'll bring the 9 to the other side, so minus 90. So I have 29y equals 3 minus 90 is negative 87, and so y is equal to, okay, I'm pretty sure that's going to be equal to negative 3, but let's just confirm. Okay, so here we have negative 87 divided by 29, okay, negative 3. Okay, so our y value is equal to negative 3, and so now we found one of our solutions. We found the y value that solves these equations. Now to find the x value, okay, I need to substitute this back into any of the original equations. Okay, since they're the same in both, doesn't matter which one I use. I'm actually going to use this here because I've already isolated the x. So it sort of makes my life easier to now determine x. I can now, wherever I see a y, replace that by negative 3. Okay, so x is equal to 6 times negative 3, my y value, plus 30. Okay, and here we have x is equal to negative 18 plus 30. Okay, and so x is equal to 12. Okay, so the solution to this system of equation is y equals negative 3, x equals 12. Now, if the question was to find the point of intersection between these two lines, I would give my answer as ordered pair 12, negative 3. Okay, so let's just recap. Look for a variable that can be isolated easily. By the way, notice here it can be the x, doesn't have to be the y. So since I'm not graphing these equations, I don't have to isolate the y. I use whichever one is easiest. Isolate it, substitute that into the other equation, which I haven't used yet, solve the equation, and then substitute back to find the other variable. Okay, that's it for this one.